Hello everyone. This is a probability question. The homework 9, the second question. It's about the Poisson process, and it's not exactly the Poisson process. And we define a new stochastic process, like something like the random walk. It's the when n is the number of the random points arrived in a time zone. When n is odd, and it gets 1. When n is even, it gets -1. So something is really like the random walk. So the first question, they want to ask to find out some couple samples. So the samples means we want to see by the time it goes on, what's the differences, how it develops. So we can see here, it's a one sample. Like here, when t, maybe n is odd, and we get it's 1. And maybe it's when in this time zone, maybe it's also is odd, so we get another. Add 1 here, but here maybe it's even, so we get -1. That is, we jump down, we go down one unit, something like that. So it is a sample, and we can see another sample. Maybe there is another possible probable situation, something like that. Go up, and go up 3 steps, and go down, and something like that. So it's the first question, the couple of samples. The second question is it want us to find this thing, xt equals to 1, the probability of this. So that means xt equals 1 equals to 1. That means it is when n is odd, right? It is when n is odd. So we wanted to find the probability of n is odd. Something like that. So we can see this is the Pn's probability. And actually it is a Poisson process, so it is this process. I want to see it is a Poisson process. And the second, we think about, if we think about here, we add the -1 square, not square, the n k, and we subtract them and get half of them. We will delete something, the even terms, right? So we delete the even terms. So only thing we get is the odd terms. That is when n is odd. Actually, the k means the k is odd, right? So here we can get answer like that. The third question is find ext. Ext, we can think it is a random walk. That means first we should think about what's the random variable of such the statistic process. We can define xnt is a random variable, something like that. And you can see here is s. S means actually it should be 1. I prefer use 1 because here the xt equals to 1 if n is odd, so I prefer use 1. So here k means the number of the odd, and n means the total number. So how we get this? It is from k is odd, so we can multiply 1 and -1 plus, and the rest so we can get n minus n plus 2k. It is the answer, like that. So we can see p xt equals to rs. That is, we want to find the probability of such the random variable. So we said it equals to a specific number, right? Here, I prefer to use 1, not because here s equals 1 equals to r, and we can get what's r? R equals to, oh, sorry, what's x? X actually equals to n plus r, the half of them. So this is the answer. So we get we substitute every k by using these terms, so we can get the answer. It's this. And here we can see, actually, we use another expression to want to show the xt. Xt means the here actually means the all the guys are added up. That is so something like that. When n is 5, here you can see from the beginning to n is 5. We can say go up, or go down. So that means we add or subtract by 1. So xt means all the things are add up or delete, and we get the answer. And then we use another expression here. Yi means that every moment, every t. Here yi can be 1 or minus 1, and if we add up them together, we will get answer. So they are the same, and we get answer. It must be 0. Yeah, must be 0. So, and the D, we want to know the R, T1, T2. Here is really similar to the when we talk about random walk. We should first think about T1 equals to nt and T2 equals to nt. And we define this, and we think about two cases: the T1 smaller than T2, and we get here. It's a definition. But here we can, because T2 is larger, so we can use the two terms to re-expression the T2, something like that. And because of the two guys, here we get answer 2 minus n, right? And here we find it is equals to 0, so we find answer something like that. And the last one, we wanted to know it is not WSS or SSS, because the R is not just about the it is about the time, the T1 or T2, right? And it is marked off because it's only it only depends on the last time, not the time ago, not the past. So here it is increment independent, because the winner process is actually it is a independent increment, and there are some similar things. That's all.